multiple choice question. In this case, this video is going to be empirical formula and molecular formulas, all that kind of method. So 5 grams of oxide contains this much of molybdenum. So therefore, 5 minus 4, you can clearly see from the options, we've got only molybdenum and oxygen. So therefore, the mass of oxygen is that. Therefore, the moles of oxygen is 1 divided by 16. Was it 32? 16 to molybdenum, which is 4 divided by MO, which is if you look at the periodic table, and you should find it 96. 1 divided by 16, 1.0625 to 4 divided by 96, 0.04167 divided by smallest ratio, answer divided by 0.065. I get 1 to 2 over 3 mole ratio. Therefore, we times by 3, it's a 3 to 2 mole ratio. Therefore, it is, and this 3 to 2 mole ratio. And what is this? Well, this 1 is the oxygen. This is the M. Yeah. So therefore, it's going to be MO2O3. It's 3 oxygen, 2 MO. So therefore, the answer is C. Question 4. Was empirical formula of an oxide of nitrogen? Contains 26% nitrogen by mass. Therefore, to find out the percentage of oxygen by mass, it's just 100 minus 26. Find out the moles. 26 divided by 14 to oxygen 74 divided by 16. 1.857 to 74 divided by 16. 4.625 divided by 1.857, 1 to 2.5 mole ratio, where this is the nitrogen, this is the oxygen. Therefore, we want empirical formula, simplest whole number, times by 2, 2 to 5 mole ratio, so N2O5. Not mole ratio, empirical formula. What is empirical formula? Hydrocarbon. Hydrocarbon contains 9% carbon by mass. Hydrocarbon's atom contains molecules of carbon and hydrogen only. Therefore, we've got 10% left of hydrogen. Find out the moles of hydrogen. Equals 10 divided by the MR1, which is 10. Moles of carbon, 90 divided by 12 to 10. 90 divided by 12, 7.5 to 10. We would now divide by smallest mole ratio, 10 divided by 7.5. So we get 1 to 4 over 3. And obviously this is the carbon and this is the hydrogen. Times by 3, C3H4. Answer C. Question 1. Should be molecular forms compound. Let's add them all up to make sure it adds up to 100. It does. Now work out the moles of each one. 40 divided by 12. 3.333. Hydrogen 6.7 divided by 1, so 6.7. Oxygen 53.3 divided by 16, not 32. 33125. So that's the special part. This was 3.3 recurring divided by small ratio. 3.333 divided by 3.33125. I get 1 to 6.7 divided by 3.33125. 2, and then that's obviously going to be 1, so it's going to be CH2O. but you can clearly see none of these have that. So it's asking for the molecular formula. So all I have to do now is I want 2 carbons, I need to times this whole thing by 2, C2H4O2. Same thing, this is the molecular formula, this is empirical formula, C2H4O2, there we go. And this final question looks like a lot of working out, but this is a quick trick and you can solve it pretty easily. 2.4 grams of explosive J contains this much of nitrogen, contains this percentage of carbon, and this percentage of hydrogen. The remainder of J is oxygen. What's the empirical formula? Well, I can just do this method, moles, and I can see in here the molar ratio of carbon to hydrogen 4 to 1. In this case, it's 1 to 2. In this case, it's 2 to 1. In this case, it's 1 to 1. So they're all different. So if I find out number of moles of carbon and hydrogen divided by smallest number ratio, molar ratio, I can easily find out the answer. Carbon, hydrogen, 33.8 divided by 12 to 1.41, because you just divide by 1. 2.8167, 1.41 divided by smallest number. I get 1, that's a hydrogen, to 2.8167 divided by 1.41. 1 to 2 is 1.9976, so we can say 1 to 2. So therefore that is the ratio, 2 to 1, carbon to hydrogen. Therefore the answer is C. That easy. That's the end of the multiple choice questions.